All right, this lecture is intended to recap the information that we went over in person this week about statistical significance. And the idea of giving you multiple exposures to this information is because it can be difficult to grasp the first time, and being able to kind of revisit and review and reflect on it is useful for hoping to make it stick. So, the learning goals for this particular lecture are to understand the logic of null hypothesis significance testing, and then more importantly, to understand how to interpret the results of a null hypothesis significance tests. As I'll note as we go through this particular lecture, understanding the logic of the null hypothesis significant testing is less important overall than understanding how to interpret the results, at least for the purpose of assessing you on examinations. But as much as possible, I really want you to understand what's happening under the hood below these statistical analyses that we're going to be conducting. So first, what is null hypothesis significance testing? It's a statistical approach that assesses where there is evidence for or against a researcher's hypothesis. The thing that makes it kind of confusing and kind of complicated is that it's relying on falsification, which means obtaining evidence for something by demonstrating what it is not. So there's kind of double negatives built into this whole process that make it kind of difficult to wrap your head around, which again is why it's important to have multiple exposures to this information, hearing it multiple times explained in different ways so that hopefully it's going to stick the more that you hear it. Reiterating this again, the rest of this lecture is a bit complicated, but it's going to boil down to one simple idea. And that idea is this: if P is less than 0.05, we interpret our test statistic. That test statistic being Pearson's R, our beta coefficient, our T statistic, or our F statistic. If P is greater than 0.05, we interpret our test statistic as 0. So essentially, all NHST, this process that we're going through, is leading us to do is to make a conclusion, and it's one of two conclusions. Is P greater than 0.05, or is P less than 0.05? The simplicity of that decision kind of belies how difficult and confusing maybe the underlying process is, but when it comes down to it, when it comes down to assessing you on exams and when you're actually interpreting the analyses that you're conducting, it's really just this quick, easy decision. Is P less than 0.05 or is P greater than 0.05? So do your best to understand the details, but the simple idea is really all that you're going to need to know in order to get through assessment situations. So I say that not to make you tune out, but to emphasize, maybe lower the stakes on maybe getting this the first time that you hear it. To recap where we've come so far, we've talked about 4 different statistical tests so far this semester. We've talked about tests of relationships, which are typically used in survey study research, including Pearson's R, our bivariate analysis, and multiple regression with a beta coefficient, which is our multivariate analysis. We've also talked about tests of differences, which are often used for experimental designs, our T statistic, which is for bivariate analyses, and our F statistic, or ANCOVA, which is for multivariate analyses. Now, what we haven't talked about is that every time I run a statistical test, I'm going to get 2 numbers. So far, we've been focusing on just one of those numbers, a test statistic, either R, beta, T, or F. And with each of those analyses I run, I'm going to get a second number, which is a p-value. And the p-value is the focus of this particular lecture, because it's going to tell us something we've kind of been ignoring in our previous lectures, where we're just kind of focusing on the test statistics themselves. It's going to tell us what we should really be thinking about those test statistics. So this p-value is really the emphasis that we're placing on this particular set of lecture slides. And just to kind of reinforce what I'm saying here is that each time I run an analysis, it's going to give me 2 numbers. When I run a Pearson's correlation analysis, I'm going to get an R value as well as a p-value. When I run a multiple regression, I'm going to get a beta coefficient as well as a p-value. When I run a T test, I'm going to get a T statistic as well as a p-value. When I run an ANCOVA test, I'm going to get an F statistic as well as a p-value. These numbers here are all made up, so don't worry about these particular numbers. I'm putting them up just to emphasize each time I run one of these analyses, I get the test statistic and I get the p-value. And when I'm interpreting the result of my test, I need to account for both what the p-value says as well as what the test statistic says. So far, we've delved into what R means, what beta means, what T means, what F means. In each case, is there a correlation? What does the correlation look like? What does the mean difference look like? Now we're going to talk today about what the p-value means, and what does the p-value tell us what we should be thinking about those test statistics. So NHST relies on what we call the null hypothesis. Before I tell you about the null hypothesis, let's revisit what we mean by a research hypothesis. So this is the statement about the relationships among variables that a researcher intends to study. It's often abbreviated with this notation called H1. So HI, H1, whatever you want to say. If you have multiple research hypotheses, you would enumerate them like H1, H2, H3, H4, H5, and so on. And let's start with thinking about tests of relationships. So if I'm thinking there's a relationship between social media use and attention problems, I might make a prediction that social media use is positively associated with attention problems. In other words, I'm going to see an R value that's greater than 0. I think the correlation I'm going to see is going to be bigger than 0. The null hypothesis is the inverse of my research hypothesis. It's typically a prediction of no relationship or no effect. So when I'm thinking about tests of relationships, it's the inverse of what I've proposed in my research hypothesis. So if my research hypothesis is that I will see a positive association between social media use and attention problems, then my null hypothesis is that social media use is unrelated to attention problems. R equals 0. I'm going to see no relationship between these variables. So H1, my research hypothesis is R greater than 0. My null hypothesis is R equals 0. My null hypothesis of HO, H0 is typically the notation for that, and R equals 0. The notation is actually helpful here because in general, we're thinking that hypothesis is no relationship, no difference, 0. So 0, no relationship. You can think about it that way. Now imagine we conduct a survey so we can kind of demonstrate what the p-value is going to tell us here. Imagine we conduct a survey and I find a correlation between social media use and attention problems of R equals 0.07. Yes, this is greater than 0. It's not hugely greater than 0. And so you might look at that number and say, well, is that relationship meaningful or not? Do I have support for my hypothesis or not? Do I actually say, yeah, it looks like social media use is positively associated with attention problems? Or would I say, no, actually, that's a really tiny relationship and it doesn't really matter? In other words, should I interpret R as positive or should I interpret R as 0? Do I seem to have support for my research hypothesis or do I seem to have support for my null hypothesis? My research hypothesis of R greater than 0 or my null hypothesis of R equals 0? The p-value is what's going to help us make this decision. Think about it this way. There's two possible worlds that I live in. I might live in the world of the null hypothesis, where social media use is unrelated to attention problems. Or I might live in the world of my research hypothesis, where social media use is positively associated with attention problems. And I want to know which world I live in. I want to collect some evidence and decide what does the evidence say of which world it seems that I live in. And so I collect a sample, I conduct a study, and I get this result of R equals 0.07. And my question is, given this result that I've obtained, is this evidence for living in the world of the null hypothesis, or is it evidence for living in the world of the research hypothesis? My prediction is that I live in this world of the research hypothesis, but my statistical test is going to tell me, what is the likelihood, based on this result that I've obtained, that I live in this world of the null hypothesis? What is the probability, what is the possibility, given the evidence that I've obtained, that I actually live in this world of no relationship between these variables? The p-value, the probability value, tells us what are the odds we would see this relationship in our sample if there is actually no relationship in the population. So what are the odds I would get this result in my study if in fact I lived in this world where the null hypothesis was true? The probability value is going to range from 0 to 1, Numbers close to 0 mean very low probability. Numbers close to 1 mean a very high probability. And these numbers suggest, is it a low probability that I live in this world of the null hypothesis, or is it a high probability that I live in this world of the null hypothesis? Generally, in social science research, we're using a cutoff of 0.05 for our p-value. When our p-value is less than 0.05, we say that it is a statistically significant result. In essence, the result that I've obtained suggests that there's a very low probability that I live in the world of the null hypothesis. When our p-value is greater than 0.05, we say this is a non-significant result. In other words, there seems to be a very high probability that I live in the world of the null hypothesis. So take a minute, reread that, breathe with it for a second, maybe pause the video and just kind of read it again. And then we're going to see how this looks in actually making conclusions based on what our analysis tells us. Again, we have this prediction of social media use being related to attention problems. The test we're going to run is actually focused on this null hypothesis. What are the odds that I live in this world where social media use is unrelated to attention problems? H0 being R equals 0. My null hypothesis being R equals 0. Again, I've collected a sample, I've run my statistical test, and it tells me R equals 0.07. And my question is that a meaningful relationship or not? The p-value is now going to help me make that decision. Let's imagine I've run this test, I get my R value and my p-value. The first thing I want to do is look at that p-value and understand what that p-value is telling me. In this case, I get a p-value of 0.45. What that means, in words, is that there's a high probability, about 45%, that I would obtain this estimate in my sample, this estimate of 0.07, of R equals 0.07, if I actually live in the world of the null hypothesis, where R equals 0. So there's a really high probability, again, greater than 0.05, much greater than 0.05, 45%, that I would obtain this estimate in my sample if I live in the world of the null hypothesis. And so it looks like, a pretty good likelihood that I do live in this world of the null hypothesis. So I'm going to fail to reject my null hypothesis, and I'm going to conclude that there is no relationship between these variables. My prediction was that R would be greater than 0. In this case, I'm getting evidence here that suggests, hey, it looks like R basically is 0. Yeah, it was 0.07, it was a little higher, but our p-value is telling us, hey, maybe ignore that 0.07. It looks like the evidence you've obtained here is that you live in this world of the null hypothesis. Let's look at this again. Now we're going to look at an example of differences rather than relationships, but overall the logic is exactly the same. So imagine I pose a hypothesis, again, this statement about relationships among variables that a researcher intends to study, and in this case I'm testing for differences. I'm making a prediction that my experimental group will exhibit more trouble focusing than my control group. My experimental group being those who scroll social media for 10 minutes, than my control group who just sits quietly for 10 minutes. In notation, I might say I'm going to expect to see a mean difference that's greater than 0. Similar to how I was for relationships, I was expecting an R value greater than 0. The inverse, my null hypothesis, my H0, my prediction of no relationship, or in this case, no effect, for this test of differences, is that my experimental group is going to be no different from my control group. Mean difference is going to be equal to 0. And I want to run this test, I want to run this experiment to see, do I have evidence for my research hypothesis of a different mean difference greater than 0, or do I have evidence of my null hypothesis, a mean difference equal to 0? So imagine I conduct an experiment. I have my experimental group scroll TikTok for 10 minutes. My control group sits quietly for 10 minutes. I see how long they spend on a difficult task. And I see a mean difference of about 2.32 minutes on this difficult task. You might say, okay, cool, you got that difference, but is that difference meaningful or not? In other words, should I interpret this mean difference as positive, difference greater than 0, or do I interpret this mean difference as 0, difference equal to 0? what evidence of which world do I have evidence for? Looking at these pictures again, I might wonder if I live in this world of the null hypothesis of a mean difference equal to 0. In this case, the experimental group is no different from the control group. Or do I live in the world of the research hypothesis, a mean difference greater than 0, experimental group scoring higher than the control group? Again, I collect my sample, I run my study. In this case, I get a mean difference of 2.32 minutes. And I want to know, what does this tell me about which world I live in? What evidence do I have for living in the world of the null hypothesis or the world of the research hypothesis? Once again, the null hypothesis significance test is going to look at this null hypothesis. It's going to look at my result and tell me, what is the probability you live in that world of the null hypothesis given the study that you conducted, given the evidence you've collected? And just recapping all of this again, the p-value is what's going to lead us to make that decision. Which world do we live in? The p-value, again, what are the odds we would see this difference in our sample if there was in fact no difference out there in the population? The score ranging from 0 to 1, exactly as we looked at before, close to 0, meaning a very low probability I live in that world, close to 1, meaning a very high probability that I live in that world. Generally, in our research, we're using a cutoff of 0.05, less than 0.05 being statistically significant. It's a low probability I live in the world of the null hypothesis. Greater than 0.05 being non-significant, a very high probability that I live in the world of the null hypothesis. This is the same exact slide we looked at before. I told you to pause. I'll say pause again, reread it, breathe with it for a second, and then continue. So here we are. I'm testing this null hypothesis, this hypothesis of mean difference of 0, this hypothesis that the experimental group is no different from the control group. I conduct my study, I get a mean difference of 2.32, and with every statistical test, in this case, I'm gonna also get a p-value. So imagine this came from a t-test, I got this mean difference of 2.32, and I get my p-value as well, 0.021. Here's what that means in words. It would mean that there's a low probability, about 2.1%, that I would obtain this estimate in my sample, that I would obtain a mean difference of 2.32 minutes if I actually live in the world where the mean difference is 0. Sorry, I didn't put that up. So there's a low probability, about 2.1%, that I would obtain this estimate in my sample if I actually live in a world where the mean difference is 0. So in this case, I'm rejecting my null hypothesis. It's unlikely that I live in this world of the null hypothesis. And I conclude that there is a meaningful difference between these variables. And I'm estimating that difference to be about 2.32. So in this case, I'm rejecting my null hypothesis. And in doing so, by falsification, in a roundabout way, obtaining evidence for my research hypothesis that scrolling TikTok, relative to sitting quietly, is going to lead to more attention problems. Once again, revisiting the slide we looked at the beginning, this lecture boils down to a very simple idea. If p is less than 0.05, we interpret our test statistic as it is, our r, our beta coefficient, our t, our f. If p is greater than 0.05, we interpret our test statistic as 0. Again, when p is less than 0.05, we get evidence, a low likelihood that I live in the world of the null hypothesis. And so I look to see what my test statistic is telling me. What world do I live in? When p is greater than 0.05, it's a high probability that we live in the world of the null hypothesis. And so we say, looks like this relationship, this difference is 0. So when p is less than 0.05, you look at the test statistic. When p is greater than 0.05, you just imagine the result is null, 0, nothing, nada. It's great if you can understand the details of the logic leading up to that conclusion, but the simple idea of p less than or greater than 0.05 is all you're going to need to know in an assessment situation. And so again, I say this not so that you just ignore all of this, but to say, to lower the stakes and maybe the pressure of really understanding the nitty-gritty, in a way, hopefully making it easier to understand. The good news is that JASP, our statistical program, is going to make this really, really easy for you. It's going to denote statistical significance with asterisks. So it's actually just going to tell you, look, here's a significant result, and look, here's a non-significant result. big but, for your exam, you're going to need to do it on your own. So I'll actually give you test statistics, I'll actually give you p-values, and you'll have to make sense of those numbers in conjunction with one another, and then also decide whether or not you reject or fail to reject various hypotheses. We'll get some practice doing that in class, in your checkpoint assignment. You'll have time to ask questions in lab as well. Happy to discuss this with you. But you will be expected to do it on your own for the exam, though JASP thankfully will make it very easy for the purpose of your class project. Once again, revisiting these learning goals, key things are to understand the logic of null hypothesis significance testing, and then to understand, more importantly, how to interpret the results of a null hypothesis significance test. If you're a little hazy on learning goal 1, that is okay. More importantly, feeling solid, hopefully, about learning goal 2.